3. Motions of the Earth. 3. Motions of the Earth. As you know that the Earth has two types of motions, namely rotation and revolution. Rotation is the movement axis. The movement of the Earth around the Sun in a fixed path or orbit is called revolution. Let's do. Take a ball to represent the Earth and a lighted candle to represent the Sun. Mark a point on the ball to represent a town X. Place the ball in such a way that the town X is in darkness. Now rotate the ball from left to right. As you move the ball slightly, the town will have its sunrise. As the ball continues to move, the point X gradually gets away from the Sun. This is sunset. The axis of the Earth, which is an imaginary line, makes an angle of 66.5 degrees with its orbital plane. The plane formed by the orbit is known as the orbital plane. The Earth receives light from the Sun. Due to the spherical shape of the Earth, only half of it gets light from the Sun at a time. Figure 3. 2. The portion facing the Sun experiences day while the other half away from the Sun experiences night. The circle that divides the day from night on the globe is called the circle of illumination. This circle does not coincide with the axis as you see in the figure 3. 2. The Earth takes about 24 hours to complete one rotation around its axis. The period of rotation is known as the Earth day. This is the daily motion of the Earth. Figure 3. 1. Inclination of the Earth's axis and the orbital plane. Figure 3. 2. Day and night on the Earth due to rotation. What would happen if the Earth did not rotate? The portion of the Earth facing the Sun would always experience day, thus bringing continuous warmth to the region. The other half would remain in darkness and be freezing cold all the time. Life would not have been possible in such extreme conditions. The second motion of the Earth around the Sun in its orbit is called revolution. It takes 365.25 days, 1 year, to revolve around the Sun. We consider a year as consisting of 365 days only and ignore 6 hours for the sake of convenience. Figure 3. 3. Revolution of the Earth and seasons. 6 hours saved every year are added to make 1 day, 24 hours, over a span of 4 years. This surplus day is added to the month of February. Thus every fourth year, February is of 29 days instead of 28 days. Such a year with 366 days is called a leap year. Find out when will the next leap year be. From the figure 3. 3, it is clear that the Earth is going around the Sun in an elliptical orbit. Notice that throughout its orbit the Earth is inclined in the same direction. A year is usually divided into summer, winter, spring and autumn seasons. Seasons change due to the change in the position of the Earth around the Sun. Let's do. Do you know how to draw an ellipse? Take a pencil, 2 pins and a loop of thread. Now fix these pins on a paper as shown in the figure. Put the loop on the paper enclosing these 2 pins inside the loop. Now hold the pencil and draw the line keeping the thread tight and moving the pencil along it. The figure Look at the figure 3. 3. You will see that on the 21st of June, the northern hemisphere is tilted towards the Sun. The rays of the Sun fall directly on the Tropic of Cancer. As a result, these areas receive more heat. The areas near the poles receive less heat as the rays of the Sun are slanting. The North Pole is inclined towards the Sun and the places beyond the Arctic Circle experience continuous daylight for about 6 months. Since a large portion of the northern hemisphere is getting light from the Sun, it is summer in the regions north of the equator. The longest day and the shortest night at these places occur on the 21st of June. At this time in the southern hemisphere all these conditions are reversed. It is winter season there. The nights are longer than the days. This position of the Earth is called the summer solstice. On the 22nd of December, the Tropic of Capricorn receives direct rays of the Sun as the South Pole tilts towards it. As the Sun's rays fall vertically at the Tropic of Capricorn, 23.5 degrees S, a larger portion of the southern hemisphere gets light. Therefore, it is summer in the southern hemisphere with longer days and shorter nights. The reverse happens in the northern hemisphere. This position of the Earth is called the winter solstice. Do you know that Christmas is celebrated in Australia in the summer season? On the 21st of March and September 23rd, direct rays of the Sun fall on the equator. At this position, neither of the poles is tilted towards the Sun. So, the whole Earth experiences equal days. This is called an equinox. On the 23rd of September, it is autumn season in the northern hemisphere and spring season in the southern hemisphere. The opposite is the case on the 21st of March, when it is spring in the northern hemisphere and autumn in the southern hemisphere. Thus, you find that there are days and nights and changes in the rotation and revolution of the Earth respectively. Let's do. To understand the Earth's inclination in the same direction, draw a big ellipse on the ground with the stick. Stand anywhere on the line of the ellipse. Point your flag to a fixed point far away like on a treetop. Now move along the ellipse keeping your flag always pointing towards that fixed point. In this way, the axis of the Earth remains inclined permanently in the same position. The revolution of the Earth and the inclination of the Earth's axis in a fixed direction cause seasons. Exercise 1. Answer the following questions briefly. What is the angle of inclination of the Earth's axis with its orbital plane? B. Define rotation and revolution. C. What is a leap year? D. Differentiate between the summer and winter solstice. E. What is an equinox? F. Why does the southern hemisphere experience winter and summer solstice in different times than that of the northern hemisphere? G. Why do the poles experience about 6 months day and 6 months night? 2. Tick the correct answers. The movement of the Earth around the Sun is known as I. Rotation, E. Revolution, E. Inclination. B. Direct rays of the Sun fall on the equator on I. The 21st of March, E. The 21st of June, E. The 22nd of December. C. Christmas is celebrated in summer in I. Japan, E. India, E. Australia. D. Cycle of the seasons is caused due to I. Rotation, E. Revolution, E. Gravitation. 3. Fill in the blanks. A. A leap year has blank number of days. B. The daily motion of the Earth is blank. C. The Earth travels around the Sun in blank orbit. D. The Sun's rays fall vertically on the Tropic of blank on the 21st of June. E. Days are shorter during blank season. 1. Make a drawing to show the inclination of the Earth. 2. Record the timings of sunrise and sunset at your place taking help from your local newspaper on the 21st of each month and answer the following. A. In which month are the days the shortest? B. In which months are the days and nights nearly equal? 1. Draw different shapes of ellipses by placing 2 pins nearer and farther using the same loop of thread. Notice when the ellipse becomes circular. 2. On any sunny day, take a straight stick that is 1 meter long. Find out a clean and level place on the ground. Place this stick into the ground where it casts a distinctive, sharp shadow. Step 1. Mark the tip of the shadow with a stone or a twig or by any other means. The first shadow mark is always towards the west. See after 15 minutes and mark the tip of the shadow again. By then it would have moved a few centimeters away. Now join the 2 points and you have an approximate east-west line. Step 2. Stand with the first mark to your left and the second mark to your right. You are now facing north. This fact is true everywhere on the Earth because the Earth rotates in west to east direction. An alternative method is more accurate but requires more time. Set up your shadow stick and mark the first shadow in the morning. Use a piece of string to draw a clean arc through this mark around the stick. At midday, the shadow will shrink or disappear. In the afternoon, it will lengthen. Where it touches the arc, make a second mark. Draw a line through the 2 marks